Hey guys, it's Brad Lumley. Brad at barleymob.com is my email address. If you have any questions about this video, I'm taking you through Bru'n Water version 1.16 today. I have Bru'n Water open in Microsoft Excel 2013. I have enabled macros. You will get a macro warning when this spreadsheet opens up, and you need to enable those to make sure that the spreadsheet will work for you. If you do not enable them, this spreadsheet will not calculate all of the different calculations that it does for you. The first tab you see is actually tab 0. It's the instructions, and it gives you a detailed rundown of every part of the spreadsheet, all the different adjustments you can make, and it also gives some water chemistry, brewing water chemistry theory. So it's interesting to run through, and something you should definitely take a look at if you run into any problems using the Bru'n Water spreadsheet. Okay, tab 1 is your water report input. So what you'll need to do is take the water report that you've received if you've sent your water to be analyzed by a company like Ward Labs, or perhaps you're lucky and your water provider can give you a detailed report. This should give you all the information you need to fill out this water report input. What you're going to see is you have elements on each side, elements and salts as it were. So you've got these on the left side and your anions on the right side, and you're going to fill in your milligrams per liter or parts per million. For the purposes of this sheet, those are the same, so that's what it should be listed as on your water report. So we'll get started on that. Calcium, my calcium is 28, magnesium is 15, my sodium is 2, potassium is less than 1, so I'm going to leave that at 0. That's not terribly important. And iron is actually not measured on the report that I got. Bicarbonate is HCO3, 151. Carbonate is CO3, less than 1, so again, I'm not going to put that in. Sulfate is SO4. Mine is listed as SO4-S. There may be a technical term for that, but I'm no chemist, so we'll say -S, and someone can correct me in the comments if necessary. So it says here, multiply lab result by 3 if the report is as SO4-S. So I'm going to multiply 3 times 2 is 6. Chloride is 3. Alright, so nitrate is NO3, and mine is reported as NO3-N, which is 0.6. It tells me to multiply by 4.43. So 4.43 times 0.6 gives me 2.658. Nitrite, I don't believe is listed in my report. No, it's not, so I'm going to leave that blank, and fluoride is not tested in my report. I'm going to slide down here to my reported total alkalinity, which is CaCO3 133. Alright, and my measured water pH is 7.7. Alright, so that's that. Now you'll notice as I did this, we had numbers changing down here. What we see is a green cell right here. If you get anything other than green, you'll notice as you hover over it, it says if the difference is greater than 0.5, you need to begin to question the reported concentration. So the question really comes in to whoever gave you your water report, whether or not they're giving you the correct information if this shows up as anything other than green. So that's just one thing to watch out for. So once you have that done, you can move on to the next tabs in the spreadsheet. Tab 2 is Sparred Acidification. Now you'll notice that what you put in for your water alkalinity for your water report does not carry over to here. So you want to put that figure in. So you can go back to your water report. You can go to your water report input tab. Either way, get the CaCO3 figure, which is 124 for us. So 124. And we know that the starting water pH is 7.7 on my report. and we want our desired water pH to be 6.0 is that's the default. Now if you hover over this again, it gives you some helpful information. So brewing sparge water is usually neutralized to a pH between 5.5 and 6. 6 is the default. I think that goes by the philosophy of don't adjust any more than you have to. Some people might change it to 5.9 or maybe even a little lower just to be safe. I'll put 5.9 just to have an example here. So now you put in the water volume you sparge with. Let's say that we're sparging with 3 gallons in this particular case. You're generally going to use lactic acid. Some people use phosphoric, but if you use lactic, the acid strength is going to be 88%. If you change this, just make sure that you're reading the acid strength on the container for whatever acid you're using, and you put that information in correctly to make sure it gives you the right calculation. Alright, so in the case of lactic acid, it's liquid, so this tells us we need 1.8 milliliters for our sparge water. And that pretty much sums up the sparge acidification. Tab 3 is where the fun happens. The good news about Tab 3 is everything you put in Tab 1, your water report input, will carry over here. So for the purposes of this example, since I know it's something I usually have to adjust for, let's do a very pale and rather small beer. So let's say it's a yellow balanced beer. You'll notice that you have a drop down here where you can pick, you've got amber, brown, black, balanced, malty, bitter. You can even do a user custom and create your own. And there are also many water profiles from famous brewing locations around the world. But for the interest of this example, we'll just use yellow balanced. It gives you a dilution water profile in case you have, say, extremely minerally water and you want to dilute a particular percentage. You can put that information in here. I don't do that because it's easy enough for me to adjust for what I have. So we'll just use my water as an example here, and I'll show you how I adjust. So I usually use either gypsum or calcium chloride to adjust my water minerals. My water is always calcium deficient, and I like to get that to around 50 parts per million. I just find that my yeast health tends to be better and I have better flocculation. So let's say my mash water, you need to put this information in. So if you've got 4 gallons of mash water and 3 gallons of sparge water, in this case, let's say I want to get up to 50 parts per million of calcium, and I'm going to use gypsum. So I'm going to put a number in here, and I'm going to start looking for when this changes, this finished water profile. I'm going to get that to 50. That's my goal. So I'm going to keep changing this until it gets close to 50, as close as possible. 58.7 is actually fine in this case. It gives me 2 grams of total mineral addition to my mash water. That's a pretty simple to measure, and so I'll stick with that. For my sparge water, I'm also going to add gypsum in, but only 1.5 grams. This is one of those cases where it's really nice to have a high resolution scale that will tell you at least in tenth of a gram intervals what your weight is. When it comes to sparge water, you can really kind of err on the side of caution. So if you can only measure 1 gram at a time, then just use a gram, and that should work out fine for you. So that's that. And then if I know I need to add acid, then I can put that in here as well. Now that's really where tab 4 and tab 5, or excuse me, tab 3 and tab 4 begin to work together. So we will look at mash acidification next, and then I'll show you how the two work together to give you a profile for your beer that's going to work. Tab 4 is mash acidification. Now, this is really important because the rest of your adjustments to your brewing water really don't matter if you don't get this part right. This is what calculates the malt color and acidity contributions of the different malts you're going to be using in your beer. You want to double check and make sure your mash water volume is reflected correctly. If it's not, change that. And then your batch wort volume. So in my case, I generally end up with 5.25 gallons. So that's what I'm going to put for my batch volume. So here you're going to put in your different grains. I'm going to go ahead and just delete all of these with the first one. And it's not important what you put here. This is more for your records than anything else. So this particular column, you can call it whatever you want to. So let's say we are going to use 2-row pale malt, which is a base malt, and I'm only going to use 6 pounds of it because, again, this is a small beer. Let's say I'm going to throw in a little C10 for just a little bit of complexity. And I'm going to drop this grain type down to crystal malt. You want to make sure you change that based on what sort of malt you use. And let's say I'm going to add 1 pound and 0 ounces for that. And we know that the color, which you'll also have to change, is 10. Alright, and then for even a little more complexity, let's throw a little bit of Munich in there. We'll say that's a base malt, but I'm just going to use 0 pounds and 8 ounces of that, and the color for German Munich is about 7, so we'll say 7. What this does is it looks at the acidity contribution. Obviously your roast malts are going to have a lot more. These are all rather pale, and so it's not giving us much acidity, and it's showing us that our estimated room temperature mash, once all of this is all said and done, is going to be 5.9. The acceptable pH range is said to be 5.2 to 5.8 depending on who you ask. I like to get somewhere around 5.6 to 5.7. Alright, so this is where tab 4 and tab 3 begin to work together. What I will generally do is I'll go ahead and get the water to where I want it to be as far as mineral additions go. I'll try to get it to fit this desired water profile. And then I'll make my acid adjustments based on my mash acidification tab. So I know that I'm going to need to add some acid to get this down to where it needs to be. I'm going to start at 0.5 milliliter per gallon, which is a total acid addition of 2 milliliters, and just see where that gets me. Alright, so I can see that gets me down to 5.6 immediately. So that's actually exactly what I need. You can kind of mess with this. So if you think, well, you know, I don't know if I really need to take that much off, you know, I just want it to be at, say, 5.7 or 5.8. You know, try something lower and click over here, and you can see this is adjusted, and now it's 5.7. So 5.7 sounds good. We'll leave that, and we'll have 1.3 milliliters of total acid addition. So that's how 4 works. And you will notice that you can, if you choose, to use existing water. And again, it's going to tell you you can switch back. If I didn't do anything at all to my water, if I made no mineral or acid additions, this is what my room temperature mash pH would be. It's kind of telling when you start to brew more and you realize, wow, I've brewed a lot of pale beers and I've probably had a pretty high mash pH and just never really thought about it. So kind of interesting to look at that. Finally, we'll look at tab 5 and do a short wrap-up here. So tab 5 is kind of your one-pager. What it does is it shows you everything that you've added. It's kind of a summary sheet of everything that you've done in your other tabs. So you can see here, you know, it gives you your existing, your finished water profile, all of your mash parameters, anything that you've added, and you know, it tells you for your mash water and your sparge water, tells you, you know, which brewing salts you chose to add, lactic acid you need to add, and then it has this interesting little sheet down here at the bottom that compares your water, which is going to be the red dot, with different famous brewing waters. So this one's relatively close to a Dusseldorf water that we've created here. So kind of interesting if you're the type who prints out, maybe for a notebook, you know, what you do for your brew day. I generally just add what I need onto my brew sheet in Beersmith and print it out that way. But this is kind of neat to have if you get into keeping those sorts of records. There are some additional tabs out to the right. Water knowledge, again, kind of adds some interesting information to what you might have read on tab 0. Talks about the way some of these calculations are done and what the different mineral and water salt additions do for your brewing water. There's an RA chart tab that shows you different things about the RA chart and what the different directions of the chart mean. And then the rest of the tabs are actually upgraded water report examples. So if you chose to upgrade by sending a donation, then that kind of gives you an idea of the bonus features you would have.